Good morning, students. Our new lesson is solutions and definition of the solutions. The homogeneous mixture of two or more substances is called solution. So in that solution, a component which is present in large amount is called solvent. So the component which is in large amount is called solvent, and the component which is in less amount is called solute. Less amount is called solute. So there are two components. One is the large amount component, that is called solvent, and another one is the less amount component, that is called solute. If I take one beaker here, if I take water, so that water is in large amount, so that's why it is a solvent. And if I add sugar into that water, I add sugar, so that sugar is in less amount, so that's why it is called solute. So that sugar solute completely dissolved in water solvent, so then we are getting the solution. So in that solution we have two components. So one is the water, that is called solvent, and another one is the, and here that sugar is a solute. So let me take another one. So in one beaker I am taking the water, so that water is in large amount, so that's why it is called solvent. And I add salt, then the salt is in less amount, so that's why it is a solute. Salt is a solute and water is a solvent. So the solute particles completely dissolve, that salt completely dissolve in the water, then we are getting the salt solution. And here that sugar completely dissolved in the water, so then we are getting the sugar solution. Here salt solution and here sugar solution. So these two are called solutions because these two are homogeneous mixtures. So the definition is the homogeneous mixture of two or more substances is called solution. So homogeneous means particles are uniformly distributed. So in both the cases, the sugar and salt particles are uniformly distributed, and we can observe only one phase. In both the cases, we can observe only one phase. So in heterogeneous mixtures, components are completely mixed, but all the particles can be seen under microscope. We can easily identify the components. In both the cases we cannot identify the components. For example, if I take another beaker, so in that beaker I am taking the water, so if I add starch, and we can easily identify the components. So here it is a heterogeneous mixture, and these two are homogeneous mixtures. Only the homogeneous mixtures are called solutions.
Here I am taking water as a solvent, then I am taking salt as a solute. I mix both, then I will get a salt solution. Here we got one phase solution, and we cannot find out the components in the solution. Then we can call it as homogeneous mixture. Then I am taking another glass with water as a solvent, and I add starch as a solute. In this mixer, we can find out the solute particles. So it is not a homogeneous mixer.
So in this chapter, we consider only binary solutions. Binary solution, that means two components in the solutions. In the solution, we have only two components. And next to types of solutions. So on the basis of different states of solute and solvents, the solutions are mainly classified into three types, and each one further classified into three types. Mainly classified into three types. So each one further classified into three types. So total 9 types of solutions. So types of solutions. Type of solution and solute state, solvent state example. So on the basis of different states of solute and solvent, the solutions are classified into three types. One is gaseous solutions, and another one is liquid solutions, and third one is solid solutions. So each one further classified into three types. So total 9 types of solutions. So let me take the number one, gaseous solutions. Gaseous solutions. So in this gaseous solutions, the solvent state is gas, and solute state is also gas. So then we can call it as gas in gas, gas in gas. Example, mixture of O2 and N2, mixture of O2 and N2 gases. So the O2 is in, for example, the O2 is in less amount and N2 is in large amount. So then the O2 present in N2. So both are gases, the gas in gas. So it is example for gases solutions. In that gases solutions, gas in gas, gas in gas, O2 gas in N2 gas. And the next one, the solvent is in gas state and solute is in liquid state. So liquid in gas, example, chloroform. Chloroform mixed with N2 gas. Chloroform mixed with N2 gas. So chloroform is in liquid state and N2 is in gas state. So the liquid in gas. So liquid in gas, chloroform in N2. And the next one, so here N2 is a solvent and chloroform is a solute. The next one, the solvent is in gas state and solute is in solid state. So solid in gas, example, camphor C10H16O. The camphor in N2 gas, camphor in N2 gas. So camphor is in solid state, N2 is in gas state. So N2 is in large amount and camphor in less amount. So it is a solute and it is a solvent. So solid in gas, example, camphor in N2. So this is the first type, gaseous solutions. And the second one, liquid solutions. Liquid solutions. In this, the first one, the solvent state is in liquid and solute state is gas. So the gas in liquid, Example O2. O2 gas dissolved in water. O2 gas dissolved in water. Water is a solvent and O2 is a solute. So water large amount and O2 less amount. So O2 dissolved in H2O. So gas in liquid. And the next one, the solvent is in liquid state and solute is in liquid state. Both are in liquid state. Liquid in liquid. So here ethanol. Ethanol is in liquid state. So that ethanol dissolved in water. Ethanol dissolved in water. So ethanol in liquid state, water also liquid state. But water is a solvent and ethanol is a solute, because water is in large amount, ethanol is in less amount. So ethanol in H2O, ethanol dissolved in H2O. So liquid in liquid. And the next one, the solvent state. The solvent state is liquid and solute state is solid. So solid in liquid. Example, glucose dissolved in water, C6H12O6 dissolved in water. So glucose is a solute and water is a solvent, because glucose is in less amount, water is in large amount. So glucose dissolved in water, solid in liquid. And the next one, third one, solid solutions. Solid solutions. So here the solvent state is solid and solute state gas. So gas in solid, gas in solid. Example, solution of H2 in palladium. So H2 is a gas and palladium is a solid. So H2 in palladium. So palladium is in large amount. So it is a solvent, and H2 is in less amount. So it is a solute. So H2 in palladium is a gas in solid. Gas in solid. And the next one, the solvent is in solid state and the solute is in liquid state. So liquid in solid. Liquid in solid. Example, amalgam of mercury with sodium. That amalgam of mercury, Hg, with sodium. So Hg is in liquid state and sodium is in solid state. So sodium is a large amount and mercury is a less amount. So sodium is a solvent and mercury is a solute. So amalgam of mercury with sodium is a liquid in solid solution. Liquid in solid solution. And the last one, that solvent is in solid state and solute also in solid state. So solid in solid. The best examples, ornaments, you know that copper. The copper dissolved in gold. The ornaments made by combination of copper and gold. Combination of copper and gold. So gold is in large amount, so it is a solvent, and copper is in less amount, so it is a solute. So copper dissolved in gold is a solid in solid. Solid in solid solution. So both are in solid state. copper solid, and gold also solid. The gold means AuRm. So that solutions are mainly classified into three types: gaseous solutions, liquid solutions, and solid solutions. And each one further classified into three types: gases in gases, example O2 in N2, and liquid in gases, chloroform in N2, solid in gases, camphor in N2. And next, the liquid solutions also classified into three types: gases in liquid, O2 dissolved in H2O, liquid in liquid, ethanol dissolved in H2O, solid in liquid, glucose dissolved in H2O. And the last, the solid solutions further classified into three types: gases in solid,
H2 in palladium.
and liquid in solid, amalgam of mercury with sodium. And next, solid in solid, copper dissolved in gold. So these are the 9 types of the solutions.